Today we're going to look at two special types of parallelograms, the rectangle and the rhombus. First, we're going to talk about the rectangle. And a rectangle is a parallelogram that has four right angles with four right angles. Okay, so then what observations can you make about the angle measures, side lengths, and diagonals? Well, like we said, there's four right angles. Now, if a rectangle is a parallelogram, then what properties exist? So all the properties of a parallelogram. And I don't want to take our time writing out all of these. You can look at the properties from our previous notes. But two other properties that we will have. The first one is, like we said in the definition, that each angle is 90 degrees or a right angle. And the other property is that the diagonals are congruent. Diagonals are congruent. Now, we talked about the diagonals bisecting each other in a parallelogram, but in those parallelograms, the diagonals weren't congruent. If we have a rectangle, then the diagonals are congruent. So we're going to draw this diagonals and look at complementary pairs of angles. So let's do that again. Draw in our diagonals. And since the diagonals are congruent and the diagonals bisect each other, you actually create two sets of congruent triangles. You have these smaller triangles on the left and right. These two triangles are congruent. And these two triangles are congruent. Okay. So what that means is that if you have your angles, that these four angles are all congruent. And let's use a different color. And that these four angles are congruent. And if you take one of the pink angles and one of the purple angles, they will add up to 90 degrees. So let's apply this. So given this rectangle below, find all the angles that are 30 degrees and find all the angles at point E. So using what we just talked about, how each whole angle here in a rectangle is 90 degrees, and that these two angles have to add up to 90, what we can do is go on and say, well, if I do 90 minus 30, that gives me 60 degrees. So that angle right there is 60 degrees. Well, considering what we just labeled over here, we can fill in all the angles on the corner of our rectangle. So this is 60 degrees, 60 degrees, 60 degrees. And these angles here are 30 degrees. So I have all of those filled in. Now, part B says find all the angles at point E. Well, at point E, we have four angles here, but these two angles are congruent because they're vertical, and these two angles are congruent because those are vertical. So we can just find one of those angles and then fill in the rest. And it doesn't matter which one you find first. I'm going to start and look at this triangle. And we know all the angles in a triangle add to 180. And I have two angles that are 60. So 60 plus x equals 180. I'll combine my like terms. I get 120 plus x equals 180. And then when I subtract 120 from both sides, x is equal to 60. So that means that these angles right here are 60 degrees. Well, we can then figure out what one of the red angles is going to be by one of two ways. You could say, well, this is a straight line right here, so I can do 180 minus 60. You could also look at one of these triangles and do 30 plus x equals 180. Either way is okay. I'm going to do the 180 minus 60, and that gives us 120. So you can see that once you really know one angle in this situation, all the others kind of just fall into place. And it's just simple subtraction to get everything else. All right, so let's look at the next page. So we have another rectangle, and the diagonals of the rectangle intersect at point T. Given that the measure of angle RPS is 62 degrees and the length of QS is 18, find the indicated measures. So first we're trying to find the measure of QPR. So QPR is this angle right here. So that angle is going to be 90 degrees minus 62 degrees and gives us 28 degrees. So what that allows us to do, say, okay, this is 28 degrees. This is 28 degrees, 28 degrees, 28 degrees. And the problem may not ask us for all of this information, but we know it, so why not just fill it in just in case? Now the length of ST. Okay, we are given that QS is 18. So from Q to S is 18. So S to T is half of that. So that is going to be 9. And then PR, from P all the way to R, well, that is the other diagonal. And we know that in rectangles, the diagonals are congruent. So if QS, that pink line, the whole pink line was 18, that means PR has to be 18 as well. And then finally, the measure of PTQ. PTQ is this angle right here. So we can do 28 plus 28 plus x equals 180. 28 plus 28 is 56. So 56 plus x equals 180. And we can subtract 56 from both sides. And we get x equals 124 degrees. All right. Now, you could have also used the exterior angle theorem, but I know a lot of people struggle with that. So I'm not going to really talk about it. But if you're looking at this and saying, well, can't I just use the exterior angle theorem to get this right here? You could, adding 62 plus 62. But if that doesn't make sense to you, then just stick to this and you'll be just fine. So what I want you guys to do is I want you to try this one down here. So pause the video and then once you are done, unpause it and we'll check our answers. All right, so here are the answers. The tricky one may have been C, ME, but if we know that CE was 9, ME is just half of that. So that's how you get 4.5. So we're going to move on and talk about rhombuses. So in a rhombus, all the properties of a parallelogram exist. All properties of a parallelogram. And we're not going to spend our time writing all those down once again. So besides all the properties of the parallelogram, with a rhombus, all sides are congruent. All sides are congruent. We also have diagonals bisect opposite angles. So the diagonals bisect opposite angles. So what I mean by that is if I have my diagonals drawn, what happens is that these four angles are congruent and these four angles are congruent. Notice that the diagonals aren't congruent, but they bisect these opposite angles. And then the last one, the diagonals are perpendicular. Remember that upside down T is a symbol for perpendicular. So we have a right angle there. Okay, so in a parallelogram, the diagonals bisected each other. In a rectangle, the diagonals were congruent, but not perpendicular. And in a rhombus, the diagonals are not congruent, but they are perpendicular. So we're really going to spend a lot of time focusing on the diagonals later on. So it's important to realize what shape goes with which characteristics of the diagonals. All right, let's look at the next page. And given the figures are rhombuses and the two rhombuses are congruent, so the reason why they're both here is to kind of, if you need more room to draw something, you have another rhombus there to use. But we may not need it. So find all the angles that are 35 degrees. So based on what we have up here, these angles are 35 degrees. And then part B, find all the angles, all the angle measures in both figures. Well, we can find these smaller angles here by realizing that the diagonals make a 90-degree angle. So we have one angle that's 35, one angle that's 90. So we can do 35 plus x plus 90 equals 180. Combine your like terms. You'll get 125 plus x equals 180. Subtract 125. X is equal to 55. So all of these angles here are 55 degrees. Now the second picture, we do have like the bigger angles to talk about, because each of these parts are 35. So altogether, they would be 70, 35 plus 35. And then over here, 55 plus 55 would give you 110 degrees. So, you could always go either way when you're trying to find out these angles in the rhombuses. Let's look at example number 2. So we have a lot to find. So what we'll want to do is label what's given. We have 34 degrees right here. We have WV is 7, and VZ is 9. So VZ is 9. All right, so the measure of angle WZV. WZV is this angle right here, so that is also 34 degrees. And I see that there's a lot of angles I'm going to have to calculate, so let me put those in. The measure of angle ZVY. ZVY. Well, that is where the diagonals intersect, so we know that's going to be 90 degrees. The measure of angle ZYV. ZYV. So this angle right here. Well, again, we have two angles. We have the 34 degree angle and the 90 degree angle. So we could set up an equation to solve that. We can set that up as 34 plus 90 plus x equals 180. When we combine like terms, we get 124 plus x equals 180. And then when we subtract 124 from both sides, we're going to get 56. So we get 56 degrees. So I'm going to write this down in all of these, just so we have it. Letter D says the measure of angle XYZ. So XYZ is that whole angle there. So we're going to do 56 plus 56. And that's going to give us 112 degrees. And then WY, how long is WY? Well, WY is 7. Sorry. Well, WV is 7, but we want to go to WY. So since this is a parallelogram, it's a rhombus, but a rhombus is a special type of parallelogram, we know that the diagonal is bisected. So from V to Y is also 7. So 7 plus 7 is 14. Okay. And then the last one we're trying to find is ZW. Well, ZW is right here. Oh, we don't know anything about that. Well, we can calculate it because we know that this is a right angle. And that gives us a right triangle where one side is 7 and one side is 9 and the other side is x, what we're trying to figure out. So we can use the Pythagorean theorem. A squared plus b squared equals c squared. So 7 squared plus 9 squared equals c squared. And you know that c squared is what we're trying to figure out because this side does not touch the right angle. So we get 49, 7 squared is 49, plus 81 equals c squared. 49 plus 81 is 130. And then when you square root both sides, you get 11.4 equals c. So that is your answer. So the biggest issue that I think you guys are going to run into is that figuring out and realizing what things are set equal to, what algebra do you need to set up to solve this? The properties themselves are not too difficult. It's just using them with the algebra is where we usually run into some issues. So I want you guys to try this example down here. It's just like the one above. So pause the video. If you get stuck, you can even rewind a little bit and see how we did it up here. So pause the video, work on this, and then when you're done, unpause it so you can check answers. All right, so here are the answers. And what you'll notice is at the very beginning, what you had to do is this whole angle here was 100 degrees. So you had to do 100 divided by 2 to get 50. And then everything else could fill in nicely. For letter F, you were given the hypotenuse or the C value in the Pythagorean theorem. And we were trying to find one of the legs. So that's why your Pythagorean theorem should have been set up like this. And then that would have given you the answer of 6. So I hope that this video was a good summary and introduction to rhombuses and rectangles and how you can use algebra to solve for parts of them when you're missing certain measurements in these shapes. We'll continue to work on these, and we'll also talk about another parallelogram later on. So thank you for watching. Make sure to like the video and subscribe.